Okay, so today we are going to talk about the composite good. Start with a composite good. So, so far we were looking at the situation where there are only two goods, right? But of course, in the real world, there are more than two goods, maybe three, four, five, millions, billions, right? So analyzing everything with the too many goods will be quite inconvenient, right? I mean, not that we cannot do it. There is a way of doing that. It's just inconvenient. So, convenient way of dealing with this many commodity situation is that putting all the goods into a single good. So, in the sense that, so suppose you're interested in good one. Okay, so you're interested in only the first good, good one, and the other goods you're not so much interested in it, right? So the budget line will be I is P1 times X1 plus P2 times X2, da 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 da, Pn times Xn, right? So this will be the expenditure on the other goods, right? So this is expenditure on the other goods, right? So instead of saying that I'm spending money on the second good, third good, fourth good, and so on to nth good, we're just gonna say that I'm consuming composite good. So composite good is the combination of all the other goods other than the first one, right? So suppose, let's say you have $200 and you spend 6 unit and you bought the 6 units of the first good at $3, and then the other will be how much? Then the other will be 188, right? I'm sorry, 182, right? So that will be the expenditure on the other goods. So you're spending $182 on the other goods. So instead of saying that I'm spending $182 on the second good, how much, third good, how much, I'm just gonna say that 182 is 182 units of the composite good at $1. Okay, so that's going to be a convenient way of dealing with the other goods that we are not interested in so much. All right, so so we're aggregating all the other goods into a composite good and consider the composite good as a good two. That's on the y-axis, right? And this composite good is measured in terms of the total amount spent on them. So in this numeric example we had, $182 were used for the other goods, and we say that I bought 182 units of the composite good at $1. All right. So this is just this is just a normalization. If you want, you can say that you bought the 91 units of the composite good at $2. So this is certainly doable. It's just a matter of a normalization. So instead of saying 182 times $1, you can say the 91 times $2. But why bother $2 when you had the simple $1, right? So this is going to be the convention we use. Okay. Then the slope of the budget constraint is a P1 over P2, right? But we are normalizing the composite good as $1. So this is going to be simply P1. So the slope is going to be simply P1 or negative P1, depending on which textbook you're referring to. All right, so that's going to be the convention. Now we're going to compare the statistics. So far, we were solving just an optimization problem, right? So for given prices and income, we know we know what the optimal decision is, right? But the comparative statics, we're going to change P and Q and see how how your optimal decision will react to the change. Okay, so so that's the comparative static. So more formally, you're going to change exogenous variables and see how the endogenous variable changes. Okay, endogenous variable change. So that's going to be something we're going to do. Okay, so in this specific context, when price of this good change, when income changes, what happens to the optimal decision? Okay. Um, so basically, so we were solving the maximization problem of uh, consumer subject to the budget constraint, right? Well, to be precise, this is inequality condition, but assuming the non-satiation, this is just going to be equality condition, right? So anyway, so the solution will be given x1 star and x2 star, and the exogenous variables are income P1 and P2, right? So in fact, for different value of P1 and P2 and I, the optimal decision x1 and x2 will change, right? So in that sense, we can think of this as a function of the endogenous variables, right? For different values, the prices and income, there'll be new optimal decision. And if you keep changing, and if you consider all the possible P1 and P2 and I, then you'll be able to basically draw a function or derive a function, right? So that's how we consider the demand function. So we say demand function, that usually means this one, okay? So let's see what happens. Okay, so suppose this was the initial budget constraint. Okay, so this was the initial budget constraint, and your optimal decision was E0. Okay, now, so let's say P1 has gone up. Okay, so initially this was I this was I over P1, but now this is the new um, a point that's given by I over P1 prime. You know, P1 prime is larger than P1, so I over P1 prime will be smaller than this one, right? So at the new budget constraint, so this is the new budget constraint, your optimal decision is somewhere here, right? So using that, you can see that what happened, oh, not this one, what happened to the optimal decision for X1, okay? So optimal decision has gone down. So price goes up and demand goes down. That's a very familiar situation, right? However, we can certainly imagine this kind of the second graph, right? So there is nothing wrong with the second graph. I mean, maybe slightly misleading, but we can certainly think of this kind of indifference curves, right? Right. So my drawing is not perfect, but they're all convex and smooth and nice. Okay. So if that's the case, what happens here is that at the initial budget line, your optimal decision was here. But under the new budget line, your optimal decision is here. So what happened? Your optimal consumption of the first good has gone up. Okay. So here, the same thing, right? So price has gone up and the consumption has gone up. Well, that's a very strange thing to imagine, but when you see the graph, there's nothing wrong with this graph. So we can imagine this is possible. So in fact, um, I'm sure you heard of this word Giffen good, right? So this was reported by Giffen long time ago. So in 1 year, there was a very bad crop for the potato in Ireland. Ireland. In Ireland, there were yes, Ireland is sometimes not easy to pronounce for me somehow. Yeah, but so anyway, in Ireland there was um very bad crop 1 year, and the production of potato has gone down so much, right? So then what happens when potato production goes down? Then typically the price goes up, right? So when price goes up, we are expecting the consumption to decline, but strange enough, on that year, as Giffen observed, the consumption of potato has gone up even more. So that's why we start to call this kind of good as a Giffen good, because Giffen was the first one who reported this kind of phenomenon. I'm sure this kind of thing happened even before that, but this is the first time an economist actually observed it, right? So I'm really bad at numbers, so it could be 18 something or it could be 17 something. So I mean, I'm sure you can look it up when that actually happened. Um, so it's either 18th century or 17th century, but I have no idea. Or 20th. I'm sure it's not 20th century. But it could be 19th century. 19th century. Yeah. So what's going on? So how is this possible? That's something. That's a kind of puzzle we need to solve. Okay. So here when P1 goes up, if you think about it, it can actually be decomposed into the two effects. So the first is the relative price changes. So in other words, the slope of the budget line changes. So this will be a substitution effect. So if this became more expensive, then you better decrease the consumption of that and increase the consumption of the other good. So for example, if you think of choosing between the meat and potato became more expensive, then you're likely to increase the consumption of the meat and reduce the consumption of the potato, right? Well, I'm not saying you're eating more meat than potato. I'm just saying that compared to the previous year, you're eating more meat and less of the potato. Okay, so that's something very natural we can think of. So basically, we're substituting the potato with the meat. But there is this another effect, that's income effect. So if you think about the budget line, right? So this effect is coming from the um, MR is equal to the price ratio. But income effect is coming from basically the budget line. So so if the potato became very expensive, then basically your expenditure on the potato is gonna occupy more of the income. I mean, roughly speaking, the reason I'm saying roughly speaking is because X1 is actually gonna change, right? So so it's not clear if you can call it P1 and X1 increases. But anyway, so it's as if you have less money to spend on the other goods, the second good, composite good, right? So let's say I know what's your biggest expenditure. So probably the food, right? So using your allowance, okay, maybe not this pandemic era time. Okay, so before the pandemic time, which you may not know what it was like, college students, they usually come to the campus and spend lots of money on the booze, beer, soju, what else? Beer, soju. I guess that's it for college students, right? So, so you're spending. So students typically used to spend lots of money on the alcohol, right? So let's say you're spending one third of your allowance to the alcohol, okay? And one day the price of the booze has gone up by 100%. So it's now twice more expensive. Then what would you think? You will think that, wow, geez, I don't have enough money for the other goods. It's as if I became poor, right? So it's as if I don't have enough money anymore. So that's income effect. Basically, there's a decrease in the purchasing power of the consumer because, like, well, of course, the assumption here is the consumption of the alcohol is something you cannot dispense with. Okay, so you have to drink beer and the soju in your first and the second year college life, right? Well, I'm not promoting consuming alcohol. I'm just saying it. Okay, just suppose that's the case. Then and the price of the alcohol has gone up by 100%. Then it's like you have less money now because you have to drink anyway, right? So in that sense, there's this substitution effect and income effect. And substitution effect, the sign is very clear in the sense that if the first good becomes more expensive, you want to substitute it with the second one. So price goes up, the consumption goes down. So that's very, very clear. But income effect is not clear, right? So let's say you have the choice of drinking beer and the soju, okay? Okay. Or you can even make a bomb shot, right? 폭탄주, right? So you can make a bomb shot out of soju and the beer. And if you don't have enough money, what's gonna happen? Um, maybe you cannot get drunk enough, right? If you keep the same um, ratio. So when you make a bomb shot, let's say you put 1 unit of the soju and the 2 units of the beer. Okay, so that's the regular time thing you do. But now, um, um, yeah. So let's say soju is the okay. That's oh. All right. So okay. So let's be a little bit more formal. So let's say the first good is the soju, and the second good is beer. Okay, and you're living on soju and beer, right? And P1 has gone up. Okay, so when you make a bomb shot, I'm not sure if this is the official language, but I just made it up. 폭탄주, right? So let's say you used to put this amount of beer and this amount of soju to make a bomb shot. Okay, but now the soju became more expensive. Okay, soju became more expensive. So now it's P1 prime. Okay. So the substitution effect, that's clear. So now you probably want to increase the consumption of beer because the soju is more expensive than before. But if you think of the income effect, basically you don't have enough money to purchase enough alcohol anymore, right? So because the your consumption on the soju is gonna go up because P1 goes up. Your expenditure on the soju will go up because P1 goes up. So that means you have less money to spend on the beer, basically. Then what's gonna happen is that maybe the composition will change, like beer and the soju. So now you're putting more soju. So previously you could have like a 5 shot. you could have 5 shots a day, but now you can afford only 3 shots a day. Okay, so maybe you want to increase the consumption of soju because you just can't afford too many glasses of the alcohol anymore. So to get drunk quickly, you might want to pour more soju than beer, right? So that's the income effect. So basically, you became so poor, so you end up buying cheaper goods. To be precise, this is called the inferior good, right? So that's what's going to happen. So in other words, if the income effect is very strong and the first good is inferior good, then you might get more of that. So if the income effect is the opposite of the substitution effect, that means the x1 is a inferior good, and the size of the absolute magnitude of the income effect is larger than the absolute magnitude of the substitution effect, then eventually it's going to cancel out the substitution effect, and you're going to end up consuming more of the first good. So that's one of the explanation for what happened in the Ireland at that year where the potato crop was really bad. So the potato became more expensive. So the the poor people living in Ireland at the same time may want to reduce the consumption of the potato and increase the consumption of the meat. But but the increase of the potato basically made them so poor because so that instead of consuming more of the meat, they'll resort to inferior nutrition source, which is potato. Okay, so we can expect that. So one possible explanation is that the potato is an inferior good compared to the beef or the meat in general, and uh, and um, and the income effect. So the income effect was the opposite of the substitution effect, and it was very much, and the size was even bigger than the substitution effect. So they ended up consuming more potato than before. So that's one explanation. Um, Another explanation will be given when we talk about the endowment model. And the third explanation was some people believe that this actually didn't happen. So some people believe that it was just a measurement error. So in fact, some people believe that the consumption of potato actually has gone down during the this bad crop year for the potato in Ireland. Yeah, I'm not a historian and I'm not a data guy, so I don't know what the truth was, but I'm just giving you an explanation. All right, so let's look at this one more in detail. Okay, so let's talk about the inferior good and the normal good in the first place. So normal good. So we are talking about the normal good and the inferior good. Okay. So normal good is good that you increase the consumption when you have more income. Okay. So let's say initially this was the initial budget line, budget constraint. Okay. And your optimal decision was E0. All right. And when is X1 on normal good? So if your optimal decision was here, then so this brown line is new budget line, right? And if your optimal decision was somewhere here, that means your consumption of X1 has gone up, right? So if you think of this point, you can see that the consumption has gone up. This point has gone up, right? So in this region, X1 is a normal good, okay? But in this region, x1 and 1 is what? This is inferior good, okay? Because if the optimal decision was here, that means the consumption of x1 has gone down, right? So that means when you have more money, you consume less of the first good. So that means x1 is inferior good, right? So that will be the case. So it's inferior good in this region. X1 is a normal good. For the x2, it's going to be opposite, right? Here, x2 is going to be the normal good, right? Because if you think about that, your initial consumption of the x2 was here, but if the optimal decision at the new budget constraint is here, then your consumption of x2 has gone up, right? So that means x2 is a normal good. In other words, when you have more money, you increase the consumption of x2. Oh, what happened? Sorry. I want to delete it here. So all right. So on the other hand, if your optimal decision was here, then x2 is inferior good, right? Because this was your initial consumption, and if this is the new optimal decision here, then your consumption of x2 goes down, right? So that means you're decreasing the consumption of x2 when you have more income. That means x2 is inferior good, right? So in summary, if you're here, both of them are normal good, and if you're here, x1 is a normal good and x2 is inferior good. And if you're here, x1 is the inferior good and x2 is the normal good, right? Can we think of the case where both of them are inferior good? No, that's not possible because of non-satiation, you cannot have it. With the non-satiation, you end up spending all your money, right? But for x1 and x2, both of them to be inferior good, you need to decrease the consumption of x1 and x2. That means you have some money left. So that's just not possible. So both of them being inferior good is not compatible with the assumption that the preference satisfies the non-satiation. Okay, so at least one of them has to be a normal good. All right, so we'll talk about this one later. Yeah, so let's think about the substitution and income effect. Okay, so this was the initial budget line, and this is the new budget line. Okay. Um, so um, so there is a bit of a spoiler here. So this analysis of the substitution and income effect, as all the other material you learn in economics department as an undergraduate student, everything is based on calculus. So everything based on calculus means that everything is based on really, really tiny change. In other words, this infinitesimal change. So we're only talking about everything in terms of infinitesimal change, but you don't have enough math skill. So I often draw pictures, like a picture in this page. But when I draw a picture, I cannot draw an infinitesimal change, right? I have to draw a chunk of change, right? Not infinitesimal change, but a chunk of change, right? So unavoidably, there'll be a discrepancy between the calculus and the picture. So that's something you cannot help because I cannot draw the infinitesimal change. Okay, nobody can do that. So sometimes the picture does not match to the equations very well. So So anyway, so because of that reason, all the textbooks are drawing the substitution effect first, then draw the income effect. But when you look at the equations, I mean, not that I'm going to talk about that equation describing the decomposition of the total effect into the substitution effect and income effect. I'm not going to do that. But if you look at the mathematics, it doesn't matter which one comes first. Everything happens at the same time, the substitution effect and income effect. But when we draw it, we always start with the substitution effect. As far as I know, all the textbook does that. So when I first learned the microeconomics, I was trying to draw the income effect first, then draw the substitution effect. But just the picture didn't came out nicely, and I wondered why it doesn't happen that way. Why can't I draw the income effect first? Um, I thought about that. I don't think I got the answer, but I decided to just draw the substitution effect first because that's what all the textbook does. So I at least looked up other textbooks, and they were all doing the substitution effect first. And the fundamental reason is I realized later that because of this discrepancy between calculus and the diagram, okay? And somehow it turns out that if you draw the substitution effect first, then it's nicer to nicer representation of the mathematical equation, okay? Um, so basically, there's no reason why we do the substitution effect first, but that's what people do, so we're just gonna stick with it, okay? All right, so the substitution effect is just looking at the price ratio, and we can think of the substitution effect as the total effect minus the income effect, right? Because the total effect is the substitution effect plus maybe um, plus income effect, right? So to describe the substitution effect, I'm going to eliminate the income effect from the total effect. Okay, so that means, so what is the income effect? So in the previous page, I explained that the income effect is a decrease in the purchasing power, right? So again, so decreasing in the purchasing power means that when I look at the substitution effect, I should draw such that there is no change in the purchasing power, right? So what does it mean? There is no purchasing power change, but the price of the X1 has gone up. So that means I probably have to draw this line, right? Because if I do that, I can purchase the previous bundle. So that means that's roughly to say that there is no change in the purchasing power, right? But another way to look at that is I draw this line here. That means I can enjoy the previous utility, right? So in that sense, there is no change in the purchasing power. So it's not clear which lines to use to describe the substitution effect. But again, this is due to the fact that we are drawing a graph when the effects are analyzed using the calculus, right? So, okay, so there's no special reason which line to look at, but it turns out that drawing this red dotted line is more intuitive. It gives us a better intuition. So So we're going to stick with this convention. So we're going to draw this hypothetical budget line that's parallel to the new budget line. So in other words, the price ratio is the new price ratio. Okay, so this is the case where P1 goes up to P1 prime, right? So we're gonna draw this hypothetical budget line that's tangent to the old indifference, right? And we're gonna treat this point as a substitution effect, okay? So don't ask me why we do that, because it's the drawing. Drawing is supposed to be different from the calculus, and somehow this is the best way to deliver the message. So that's why people are doing that. Okay. So anyway, so this is gonna be the substitution effect. Okay. So this is gonna be the substitution effect. So the own substitution effect is always negative. It's always negative. If the consumer remains at the same level of satisfaction, which means the same old indifference curve, okay, so this is the same level of satisfaction, then an increase in the price of good X1 must decrease the quantity of X1 consumed. So when price goes up, you decrease the consumption. But there's an income effect. So the income effect is, so here, this was the substitution effect. And so since we're decomposing the total effect into the substitution effect and income effect, the other effect, the remaining effect will be the income effect, right? And this will be the total effect, right? Right? So that will be the analysis. Okay. So here, so from this hypothetical budget line to a new budget line, the income has gone down, right? So when income goes down, if the consumption goes down, we call it normal good, right? It's the opposite of what we did, right? When income goes up, consumption goes up. That is a normal good. So by the same logic, when income goes down and consumption goes down, that's a normal good, right? So here, X1 is a normal good, right? And remember, the good we're interested in is always the first good in the x-axis, okay? So consumption of X1 goes down. So that's our normal good when income goes down, right? So the substitution and effect and income effect, they're both to the same direction, and the sum of them will be the total effect. So this is how you analyze the substitution and the income effect. Okay. Okay, what is this? Okay. Now let's look at the yeah. So let's see. Okay. So how does the given good happen? So let's think about that. Okay. So let's say this is the initial budget line, and the new budget line is the one. Okay. So this is the red one is the new budget line. Okay. So, no. So this is the new budget line. And let's say okay, maybe there's a better way of doing that. Yeah. Okay, so let's say your optimal decision was here. No, not this one. So let's, yeah. So let's say your optimal decision was here. Okay, now how do I draw the, so this is the old optimal, okay? And let's draw the, let's get the substitution effect. That is, you need to draw a hypothetical budget line that's parallel to the new budget line, right? So we're gonna use this dotted line, okay? All right. So your new optimal decision, not this one. Okay. So this will be the substitution effect, okay? So so this will be the substitution effect, right? And the income effect is, all right, so here, so if the new decision, new optimal decision is somewhere here, then here is x1, then x1 is a normal good, and new optimal decision is somewhere here, that means x1 is an inferior good, right? Okay, so that's the thing. So if it's a normal good, then you're going to end up here as an optimal decision, right? Then as you see, the substitution effect and the income effect, they're to the same direction, right? So if this is the case, then the substitution effect, income effect will be here. So both of them are to the same direction. And this is a typical case, right? Price of X1 goes up, right? So this was the initially I over P1. This is I over P1 prime. So the price goes up, you decrease the consumption. Both of the substitution and income effect works to the same direction, right? Because it's a normal good. Okay, so let's think of the other case, another case. Okay, so here, so basically the same situation. Okay, so just new budget line and so on, right? So, but here, let's say the optimal decision was not here, but let's say optimal decision was here. Okay, so that means x1 is the inferior good, right? And optimal decision goes to here. So, all right, so that means income effect is here, right? So the substitution and income effect, they're to the opposite direction, right? So substitution effect makes the consumption of the first good decrease, but the income effect make the consumption increase, right? So they're to the opposite direction. But here, the size of the income effect is smaller than the size of the substitution effect. So in the end, total effect, denoted by capital T, is the negative direction. Okay, so here, the consumption of X1 still goes down. Okay, so that's what it is. Now let's look at the really extreme case. Okay, that is, all right, so let's see. So now X1 is the inferior good, but not only is the inferior good, this is a very, very inferior good. So your new optimal decision is here. Okay, so what's the indifference curve is gonna look like that. Okay, so to be precise, has to go all the way down like that, right? Okay, but let me just delete the last bits. So that means the optimal decision. So this is the and here so this will be the optimal decision. So the income effect is the opposite of the substitution effect, and the size of the income effect is larger than S. So it's not only cancel out all the substitution effect, it actually moves the consumption larger. So the total effect will be this one, which is substitution effect plus income effect. So you end up you end up buying more of the first good. So this is an explanation why the potato consumption during this that year in Ireland has gone up. Okay, so this is an explanation. All right. Um, yeah. So so for the so for the given good phenomenon to happen, it has to be a inferior good and a very, very much inferior good. Okay, so that is an explanation. So that means potato is a very, very bad food compared to the meat. Okay. Well, of course, here by mean bad, by bad, I mean that in terms of people's preference. So people consider potato is a much, much more inferior good than the meat is. Okay, so and if that's the case, then this can happen. Okay, so yeah, so this is how you define the um, price elasticity. So percent change in price versus percent change in the quantity. So um, so here, suppose this is -1. Okay, so in other words, when price goes up by 1%, quantity goes down by 1%, then that will be -1, right? So so let's say I'm interested in P1 and X1, okay? And say P1 has gone up by epsilon amount. Okay, so this is the new price. So the price has gone up by epsilon percent, and X1, the consumption of X1 has gone down by epsilon percent. Okay, that means the price elasticity is -1, right? So according to definition, P1 has gone up by epsilon percent, and X1 has gone down by epsilon percent. So that is -1, right? Then this can be rewritten as 1 minus epsilon square over P1 times X1, right? And this is almost the same as P1 times X1, right? So when we think of the X epsilon very small number, epsilon square is a really, really tiny number, so we can ignore that in the first order approximation. So so in this case, it will be the same as the P1 of P1 X1. So when elasticity is -1, when price changes, the expenditure on the X1 does not change. Okay, because whenever, we're still using the calculus. So when you think of the percent change, you're thinking of the percent change infinitesimally. Okay, so infinitesimal number squared is really, really tiny number. In fact, the definition of an infinitesimal number is that infinitesimal power to the power of 1 plus any number is going to be 0. So that's the definition of infinitesimal number anyway. All right, so that's what it is. So that means if the elasticity is larger than -1, then when price goes up, the expenditure will go down, right? So if it's larger than, I'm sorry, I should say smaller than 1. If this is smaller than 1, no, I'm confused now. Yeah, smaller than 1, -1 means -2, right? So I'm saying if the magnitude is larger than -1, which means less this is less than -1, right? Then what happens when price goes up by 1%? The demand goes down more than 1%. So for example, if it's -2, then demand will decrease by 2%. So that P1 times X1 will decrease approximately decrease by 1%. So if the magnitude of elasticity is larger than 1, I mean the absolute value is larger than 1, then uh, expenditure goes down. But if it's larger than -1, in other words, the magnitude is smaller than the -1, that means the expenditure actually goes up, right? So price goes down. No, expenditure actually goes. Yeah, expenditure actually goes up, right? So price goes up by 1%, then the demand goes down by 0.5%. That means the product of the two actually will go up by approximately 0.5%. Okay, so that's what it is. And yeah, so that's what I actually explained here, right? So when price goes up a little bit, what happens to the expenditure, right? And um, and the differentiation will come out like this. So so going up mean is the same as the elasticity is larger than -1. Okay. All right. That's it for today, and we'll talk about how to compute the substitution and income effect a bit later.